only reversible reactions can reach equilibrium. So reversible reactions are these that can occur both backward and forward and backwards. Okay, so this reaction, they don't go to completion. Okay, they occur in both directions. And we call this the forward and this the backward reaction. Okay, so we have this half-headed arrow which shows that the reaction occurs in both ways. While a reaction that goes to completion, so a completed reaction, is only shown with this type of arrow, A to B. It shows that, that's it. It ends. This is the first concept, very important to understand. The second concept is that when a reaction is in a closed system, when the rate, so it's how fast the forward and the backward reaction is the same, we say that the reaction is in equilibrium. So the effect is that it seems that the reaction has stopped changing. But this equilibrium, it's called the dynamic because the reaction keeps occurring even if it goes backward and forward at the same time. Okay, which means that it looks like it's over, but it's continuing. Okay. So this is the important concept. Now, you have to understand also that if the forward reaction is exothermic, the backward reaction is the opposite. It's endothermic. Okay? So forward is endothermic, backward is exothermic. So it's very important, to understand that. And normally you're given, if you remember the value of the enthalpy, delta H, for example, negative, this refers to the forward reaction. Okay, so those are the conditions for a reaction to set up an equilibrium. And it's important to understand the energy involved because in the next part, we will look at the effect that changes have on this equilibrium.